Hi guys, don't forget to subscribe my channel and like this video. Okay, enjoy! Now we move to the fourth principal step in gravimetric analysis, which is filtration and washing process. First, we move to the filtration. Filtration is a process used to separate solid from liquid or gases using filter medium that allows the fluid to pass but not solid. The precipitate must be separated from the supernatant solution, which normally contains excess common ion and other constituents of the sample. Normally, filtration using filter paper is used to collect all the precipitate form. Referring to these diagrams, a mixture of water and sand can be separated using filter paper in the filtration process. In this process, water will pass through the filter paper while a sand will remain on the surface of the filter paper, as we call it as a residue. And then water that pass through the filter paper, we call it as a filtrate. There are various grades of filter paper that been used in chemical process. For example, filter paper grade number 24, number 41 and number 40. Usually, they will use filter paper grade number 40 for medium or crystalline precipitate. Here are YouTube links that can give you more information about filtration process. Now we move to the washing process. Washing process is required to remove the excess precipitating reagent or excess analyte. However, do not take a long time to wash the precipitate since the precipitate form is not 100% insoluble. Many precipitates cannot be washed using distilled water because the peptidization process may be occurs. Here are the best way to wash the precipitate. Wash the precipitate a few times, not to wash once with total same volume of washing solution. Let's say the prepared washing agent is 30 ml. You have to divide into 3 portions, which is 10 ml each, to wash 3 times. So it is better 3 times 10 ml compared than 30 ml once. So here's the step that combine filtration and washing process. First, when two solutions of soluble substance are mixed together in a beaker, it will produce a white precipitate. Then, the precipitate of white salt will be filtered through the filtration process. In the filtration process, the precipitate will remain on the surface of filter paper while the excess analyte will pass through the filter paper and become filtrate. Then, the filtered precipitate is washed several times with washing agent. It is required to remove the excess precipitating reagent or excess analyte. Here are the properties of ideal washing liquids. The first one, no solvent action on precipitate. It means that no reaction between the washing agent and precipitate. This is to make sure the precipitate do not dissolve again into soluble form. The second one, the ideal washing liquid should dissolve impurities easily, which means instead of react with the precipitate, the washing agent should react with the impurities to make sure less impurities is carried out together with the product. The third one, ideal washing liquids should easily evaporate at drying temperature of precipitate. This is to make sure that no excess washing agent stick on the surface of the precipitate. Last but not least, ideal washing liquids should contain no substance that will interfere, which means it 100% washing agent that will not become impurities for the product. Next, we move to the fifth principal step in gravimetric analysis, which is drying and ignition process. What is drying process? Drying process is a process of heating the precipitate until obtain the constant mass. Usually, this process been done by heating at 110 degrees Celsius to 120 degrees Celsius for 1 to 2 hours. Before this process been done, the insoluble salt are carefully scraped off the filter paper into a dish and dried in a oven. This process is needed to remove solvent, adsorbed electrolytes, and any volatile species that is carried out with the precipitate. After drying process, some precipitate must be ignited to decompose the solid and form a compound of stable and non-composition. This process is needed until get wet form of product. Next, we move to the last principal step in gravimetric analysis, which is weighing the dried precipitate. The weighing process to get the mass of precipitate usually been done by using the sensitive analytical balance. This is to make sure to get the accurate value of weight of the product. After getting the mass of product, there are two methods to calculate the amount of analyte in weighing form. The first one is the chemical factors and the second one is the gravimetric factors. First, we look the calculation using chemical factors. In this method, the calculation of weight of constituent in a given precipitate follows directly from the proportion. So, this is the formula that been used to calculate the constituent desired, where Ma is the molecular weight of the precipitate, M, this one, is the atomic weight or molecular weight of an element, and this one is the number of atomic weight of M in the molecular weight in Ma, which is this one. W is the weight of precipitate and the X is the weight of constituent or analyte desired that we need. Then, after you get the weight of X, the percentage of X can be calculated using this formula, X times 100 per M, where X is the weight of constituent desired, which is we need this, and then M is the weight of precipitate. We will look into the first example of the calculation. In the first example, a 2 gram of an iron compound after suitable treatment yield 0.140 gram of ferric oxide. So, calculate the percentage of iron in the compound. Then, first we need to find the mass of iron in iron oxide. By using this formula, we transfer all the information from the question into this formula, which is iron oxide, and then iron that we need to find. So how we get 2 here? We can get the number of 2 by determining the number of atomic in the iron oxide. This is the mass of final product, and then this is the mass of iron that we need to find. Next, this is the molecular weight of iron oxide, and then this is the atomic mass of iron. Then, by using the mathematical problem or mathematical formula, we can get the mass of iron in iron oxide, which is 0.1218 grams. After that, we use the formula of this one to get the percentage of iron in iron oxide, which is X times 100 per M. M is the mass of iron compound. X is the mass of iron in ferric oxide times 100 over 2 grams. Then you will get the percentage of iron inside the ferric oxide. What if you try question 2? Now we move to the second methods of the calculation to obtain the mass of analyte, which is the gravimetric factors, GF. The gravimetric factors is the ratio between the grams of compound and the grams of a single element that forms that compound. So how to get or how to calculate the gravimetric factors, GF? So this is the example of the calculation. Let's say in the first example, to calculate the GF of chlorine inside the silver chloride, you must do the ratio between the element needed and the product form. To get the GF, first you must do the ratio of atomic weight of chlorine over molecular weight of silver chloride. How to get 1? 1, which means you just only have 1 mole of chlorine, and then 1 mole of chlorine inside the silver chloride. Then you insert the atomic mass of chlorine and molecular weight of silver chloride. Then you will get the value of GF. Same as with the second example, iron in iron oxide. To get the GF, atomic weight of iron over molecular weight of iron oxide. At this first part, you must over 1, which means only 1 mole of iron. And then for the iron oxide, since there has 2 mole of iron, so which means you must divide with 2. Then you will get the number of this one. Then, what is the function of GF? The function of GF to get the weight of analyte by using this formula. Weight of analyte is equal to the GF times weight of waveform, which is product. We look into first example, which is I use the same example from the previous slide. 2 grams of iron compound after suitable treatment yield 0.1740 gram of ferric oxide. Calculate the percentage of iron in the compound. So first step is you must calculate the GF, gravimetric factor. Since we need to find the mass of iron inside iron oxide, so we must compare or do the ratio between iron and iron oxide. So to calculate the GF, atomic weight of iron over 1, why 1? Because only 1 mole of iron over molecular weight of iron oxide over 2, why 2? Because they have 2 mole of iron in iron oxide. Then you will get the value of GF. Next, we can calculate the weight of iron inside the iron oxide. This is the GF times with the mass of final result. This one. Then you will get the mass of iron in iron oxide. So, why don't you try the second question? This is the solution of the second question. Did you get right? Last but not least, we look into the application of gravimetric analysis. So first application of gravimetric analysis can be look into the determination of inorganic anions and cations. The second application in determination of variety of organic substance. For example, determination of nicotine in pesticide and lactose in milk product. Now, we move to the second subtopic for this chapter, which is the volumetric analysis. Volumetric analysis is a method in quantitative chemical analysis in which the amount of a substance is determined by the measurement of a volume that the substance occupied. It is commonly used to determine the unknown concentration of a known reactant. Volumetric analysis is often referred to as titration technique. Titration technique is a laboratory technique in which one substance of known concentration and a volume is used to react with another substance of unknown concentration. I think you already done this technique during your lab session by referring this diagram. In the titration technique, the unknown concentration will be at this part, and this part, which is inside the burette, will be the non-concentration solution. Now we move to the concept of volumetric analysis. The first concept of volumetric analysis is the reactants will react with the standard solution from burette of a non-concentration called titrant. As I said previous slide, the burette will be occupied with the standard solution. We call it as a titrant. The second concept of the volumetric analysis is the analyte in which the concentration to be determined is placed in the conical flask. This one. We call it as analyte or titrant, unknown concentration, but non-volume. Last but not least, the appropriate indicator will be added in the conical flask to determine the end point showed by color changing of the indicator, which means before the titration takes place, few drops of indicator will be added inside the solution of unknown concentration. The function of indicator to determine the end point, the point where the color of the solution inside the conical flask change. Now I will explain about the requirements in the titration technique. The first requirement is the reaction should be stoichiometry. It means that when A react with B, it produces C and D in the stoichiometry form. Next requirement is the reaction should be rapid, which means the reaction can be repeated more than 3 times to get the accurate result. There should be no side effect reaction. This is the third titration requirement. It means that the reaction A and B should be directly produce C and D. Certain reaction can produce another intermediate. For example, when A react with B, it can produce E first, then E will convert into the final product C and D. Next requirement is the endpoint must be equal to the equivalent point. What is endpoint? What is equivalent point? Later I will explain about this one. Next requirement is the reaction should be quantitative. The volume that been used to reach the endpoint for the reaction in the titration technique can be used to determine the concentration of unknown solution. Last requirement is there should be an obvious change in solution properties when the reaction has complete. It refers to the endpoint of the reaction, which is the color of the unknown solution changes from one to another that indicate the endpoint of the reaction. What is standard solution? Standard solution is a chemical term that describes a solution of known concentration. From the previous slide, I already explained to you about the standard solution that will occupy inside the burette. This standard solution will be used to determine the concentration of unknown solution here. The ideal of standard solutions. The first one is be sufficiently stable, easy to determine its concentration. The second one is react rapidly with analyte. It means that the standard solution should be rapidly react with the unknown solution here. The third one is the ideal standard solution should react more or less completely with the analyte. It is to make sure the reaction between standard solution and unknown solution reach the accurate endpoint. Last but not least, the ideal standard solution should be undergo a selective reaction with the analyte that can be described by a simple balance equation. Let's look into the comparison between the primary standard solution and the secondary standard solution. First, the primary standard solution are made out of the primary standard substance. For example, to prepare the standard solution of NaCl, it can be prepared from the solid of NaCl. For the secondary standard solution, it made specially for a certain analysis. Normally, the secondary standard solution are made from the primary standard solution. For example, here, from the primary standard solution, it will be diluted to form the secondary standard solution, which is give the lower concentration compared than the primary standard solution. Next, the primary standard solution are extremely pure, 99% of the compound, because it made out from the pure solid of the compound. However, for the secondary standard solution, it not very pure, because it involves the dilution of process from the primary to secondary standard solution. Next, since the primary standard solution are extremely pure, it less or not reactive with the analyte or unknown solution, because the concentration of the primary standard solution are very high compared to the unknown or analyte solution. However, for the secondary standard solution, it comparatively more reactive to the analyte or unknown solution, because the concentration of the secondary standard solution normally are comparable with the unknown standard solution. Next, the primary standard solution not hygroscopic, and for the secondary standard solution, sometimes it give a hygroscopic properties. Last but not least, the primary standard solution are used to standardize the secondary standards at other region. As I said before, the primary standard solution usually being used to prepare the secondary standard solution. And for the secondary standard solution, usually being used for the specific analytical experiments. It means that after the secondary standard solution been prepared from the primary standard solution, the secondary standard solution will be used for the titration process. Next, we look into the comparison between the equivalent point and endpoint. First statement is, first comparison, the equivalent point is the actual point where the chemical reaction in the titration mixture ends, while the endpoint of a titration is the point where a color change occurs. In other words, if you want to indicate the chemical reaction between two analytes in the titration reaction ends by chemically, you can refer to the equivalent points. And if you want to indicate the reaction between two analytes and in the titration process physically, you can refer to the endpoint. Next is the equivalent point gives the points where the unknown analyte has completely reacted with the titrant. For the endpoint, it does not always give the point where the unknown analyte has completely reacted with the titrant. The equivalent point also not always indicated by the color change of the reaction mix, while the endpoint always indicated by the color change of the reaction mix. Last comparison is the equivalent point gives the point where the reaction ends, while the endpoint does not always give the point where the reaction ends. Based on this discussion, I can say that the equivalent point is more favorable to be used to indicate the ends of the reaction between two analytes, and also the equivalent point can give the accurate final result of the volume that been used in the titration reaction. So this is the example of endpoint. When the reaction between two analytes are reached the endpoint, the color will change from the colorless to the pink color of the solution. It means that it reached the endpoint. These are few examples of reference that you can look into to get more information about gravimetric analysis and volumetric analysis. Now we are reached the end of this topic. I hope you can understand the basic principle of gravimetric analysis and volumetric analysis. Please remember, our class tutorial will not base on the question, but you will do some activities about your understanding on gravimetric analysis and volumetric analysis. Okay, see you then. Bye!